I have this line right here. I want to find the slope. So, how do I find such a thing? Well, you may have heard this many times before, but slope, which in mathematics we denote as m, is just rise over run. Basically, that's just how far up or down you go over how far right you go. But how do you know what to even check? Typically speaking, you always want to do dots that are on whole numbers. So for example, this dot right here is at 0, 0. This dot isn't necessarily, it's at 1 for my y, but at some fraction for my x. So I'll ignore it. And instead go here to 1 comma 2. Then I can go here to 2 comma 4. Notice I'm choosing dots that are at crosshairs. So how do I find my slope? Well, exactly as the name suggests. If you're given a graph and it's at least this clear, you can do it just by sight. First, we start with our rise, and you're going to always read from left to right, as the arrow suggests. So, what's my rise? How far up or down am I going? Well, from this dot to this dot, I'm going up. How many spaces? Well, I can count it. So I went up 1, 2. And now I'm looking for my run. How far right did I go? Never to the left. Well, I went right 1 space. So my slope would be a positive 2 because I went up over a 1, or just 2. Now, I can do the same exact thing with the numbers alone. You're not going to always have a graph. Sometimes you'll just have the coordinates. So how do I find it out if I'm given just my coordinates? Well, we'll use the same exact numbers. We had one coordinate at 1 comma 2 and one coordinate at 2 comma 4. Typically, this is my x and this is my y. We still want rise over run. Rise deals with your y. Run deals with your x. So how do we figure this out? Well, we're just asking ourselves, how did I go from 2 to 4? And how did I go from 1 to 2? Well, to go from 2 to 4, I added 2. To go from 1 to 2, I added 1. So my slope should be plus 2 plus 1. Which, what do you know? That's 2, just like we had. But this method can get time consuming and costly, especially when the numbers get larger. So if I did something along the lines of 117 and 1824. Another way of looking at this exact same problem is we're going to find the difference between my y's. So that would just be, let's call this my x and my y. And just to keep confusion out of the way, I'm going to call this A and B. So I'm going to subtract my y's first. The order does not matter. In fact, I'll show both versions. On this version, I'll do my first y minus my second y. On this version, I'll do my second y minus my first y. Now, this is our rise. We also need our run. Well, we're doing the same exact thing for our run. On this version, since I started with my 17, I need to start with my 1. Likewise, on this version, since I started with my 24, I need to start with my 18. And again, it's rise over run. So it's this stuff over each other. Now, let's go ahead and start simplifying out some fractions. 17 minus 24, well, I know it's a negative number because 24 is larger. And so I'm going to do negative, and then I'm going to do big minus small. The same thing goes for the bottom. So it's going to be negative, well, 24 minus 17 is 7, over negative 18 minus 1 is 17. 7 and 17 are both prime numbers, so they can't be reduced, but a negative over a negative just becomes a positive. Let's do the same math for this one. Well, we just said that 24 minus 17 is 7, and 18 minus 1 is 17. So what do you know? No matter which way you do it, your slope will be the same. And that's slope in a nutshell. Basically speaking, it's rise over run. And you would subtract your 2 y's and then subtract your 2 x's. And that's how you would find slope given 2 points or given a graph.